Hello everyone, we are the Airflow Avengers and our project is the Smart Vent Thermostat. Welcome to our midterm design demo. Our team consists of 5 people: Andrew, who will be demoing our power system, Tommy, who will be demoing our sensors, Josh, who will be demoing our microcontroller function, Holly, who will be demoing our motor control, and me, Eliza, I'll be demoing our user interface. So let's start with a quick background for our project. Our user is Harold the homeowner, and he has recently bought an older home in the Midwest during winter, and he has noticed that because his thermostat is in an internal room, his inner rooms are at his desired temperature, but the outer rooms are still much colder and draftier, so he either has to pump up the temperature to unbearably hot in his inner rooms to make the outer rooms a livable temperature, or he has to be cold when he wants to go into those outer rooms. Because of this, he would like to purchase a smart thermostat, but he has learned that his HVAC system is outdated and does not have the communication channel needed for current smart thermostats on the market, and he does not have the funds, because he just bought a house, to replace this HVAC system. Because of this, our team has designed a smart system that will be compatible with older HVAC systems, and it consists of a central hub, which will be located where the original thermostat was in the household, occupancy sensors in each room, as well as a thermostat in each room. And the occupancy sensors track whether the room is occupied or not and send it back to the main hub, where the user can enter in a desired temperature for both an occupied and an unoccupied room. And the thermostat in each room sends back the temperature of that room currently. And the central hub will take this information and whether the room is occupied or unoccupied and check to see if that temperature falls within the range. And if it does, it will leave the vents closed so that the room remains at that temperature. And if it does not, it will open the vent so that it adjusts the heating or cooling to the desired temperature. If a certain number of rooms are outside of the range, then the HVAC system will kick on to pump the air out more adequately.
Hi, I'm Andrew Freeman with the power subsystem for the Smart Vent Thermostat. So the first major part of this subsystem is actually powering the main hub. And right here we have a 120 volt AC to 24 volt AC converter. And just to show you, right over here, we've got this hooked up to the oscilloscope. We've got an output of about 36 volts. Now, obviously, we won't want to use an AC voltage to power our DC components. So down here, we've got a rectifier that brings in the AC voltage and then uses a capacitor. And our output here is about 35 volts. We have a 36 volt output, but we only need 5 volts for our subsystem. So, an LM2596 will be used to step down the voltage. The maximum input allowed is 45 volts, and then the output is set at 5 volts. Unfortunately, the part hasn't come in yet, so we weren't able to test with this. The other half of our power subsystem will need to be powering the auxiliary systems, which will require both motor power, which is 10 volts, and control power, which is 3.3 volts. To demonstrate this, we have a 18 volt input coming into a buck converter. As you can see over here, we have 18 volts coming in. If we measure the output here, we're at 3.3 volts, which is actually the logic power that we need. Motor power will be delved by a smaller controller, about this small. So I'm not able to implement it on a breadboard. We'll have to wait for the PCB for that.
Hello, my name is Tommy Gates, and I will be demoing my sensor subsystem of our design. Now I will be showing off how our temperature sensors and motion sensors work in each room. So in order to monitor the temperatures in each room, we will be using a Texas Instruments LMT87. And in order to track the occupancy of each room and when people enter or move around, we will be using a passive infrared motion sensor. So now I will be getting into the temperature sensor of the subsystem sensors. So as you can see, this temperature sensor takes an input voltage of 3.3 volts from the microcontroller, and it is outputting a voltage inversely proportional to the temperature itself. Using this calculator here, you can see a output of 2.3 volts, and that results in about 21 degrees Celsius, which is about 69 degrees Fahrenheit in this room. So now if we warm it up by, say, touching it, we will watch the voltage drop of the output, and doing so would result in a higher temperature sensing. So now that I did that for a couple seconds, I'm going to go change our number in here, and we're looking at roughly about 24 degrees Celsius doing that. So the next aspect of the sensor subsystem is the passive infrared motion sensor, which tracks occupancies. So this sensor will take a 3.3 volt supply and output high whenever there is motion. So I've hooked up for demonstration purposes a red LED and turned off the lights so you can better see it. Whenever motion is tracked, it starts blinking. I will move into shot to show that it keeps blinking. But now, however, if I stop moving for 5 seconds or so, it will stop being able to track me. So now that it doesn't see any motion, I will start to move and it comes on instantly.
This is a demonstration of the first two microcontroller subsystem requirements. On the left, we have a stand-in for the sensor unit, and on the right, we have a stand-in for the central hub unit. The sensor unit is getting a digital voltage that corresponds to a temperature sensor value. That gets converted via the ADC into a temperature, and it has two buttons, one of which sends the data to the central hub with a tag saying that the room is unoccupied, and the right sends it with occupied tag. On the central hub, that data gets interpreted and it makes a decision about whether to open or close the vent. So I can demonstrate that by clicking the button a couple times. And as we can see, it's receiving the data, and then it's making a decision that says vent should be opened. If I turn up the voltage, we see that when the room is unoccupied, represented by a exclamation point, we get a message saying the vent should be closed, but when it has an @ representing an occupied room, it says the vent should be opened, so we're assuming that the room is being heated. This is a demo of the third requirement of the microcontroller subsystem. On the left, we have a microcontroller representing the central hub, and on the right, we have a microcontroller representing the vent unit. So right now, the vent unit output pin is set low, and when I hit the first button, that will send a signal that says the vent should be opened. So the signal stays low. When I hit the second button, representing that the vent should be closed, we see here that it says the vent should be closed, and we get a multimeter reading of 3.3 volts on the output pin of our vent unit.
Of the motor subsystem of the Smart Vent Thermostat project. The motor subsystem is responsible for turning the air vent in either a clockwise or counterclockwise direction based on the need to open or close the air vent. To accomplish this, a stepper driver will be used to drive the stepper motor. This is a look of the logic being sent to the stepper driver from the STM32 microcontroller. To start off, we have established a delay sequence. This controls the speed of the shaft of the stepper motor. We are currently operating at 1000 microseconds. Next, we have programmed the direction and duration of the motor. Currently, the logic tells the driver to turn the motor in a clockwise rotation 90 degrees, which is about 50 steps, to open the air vent. It also tells the driver to turn the motor in a counterclockwise rotation 90 degrees or 50 steps to close the air vent. In the final product, information on whether to open or close the air vent will come from other subsystems.
So here's a quick look at our graphical user interface. So to start, we have a selector between an occupied or unoccupied room. You can tap to switch, and then below that it will display the desired temperature for that room. in these question marks, and then whether the room, a string will be underneath for whether the room is occupied or unoccupied based on what you had selected above. And then there are buttons to change the temperature up or down. And then at the bottom there's a burger menu to get to other screens. So eventually, once we're able to connect via Bluetooth, there will be a screen that displays all of the connected devices. There will be a screen to change the unit of temperature that you're dealing with. And then there's themes. Right now there's light, neutral, or dark. And then you can hit the burger menu to go back to the home page, and you should have all the same selections from there.